Is my screen visible to everybody?
Yes,
Okay. Uh, I guess you joined today for the first time, right? Somebody? Or you joined yesterday's
yes,
session
yes,
also?
yes.
Okay. So since we are only four of you today, so I'll not be covering lot of things because this is a very basic and important session. But since I covered a lot of things yesterday in the yesterday session, like buffer and too many some geospatial libraries, so I'll just give you some glimpse what is the importance of Python in GIS and what are some of the operations, some of the geospatial libraries that are present, which you will be using in further classes as well, and doing some special kind of activities and new projects regularly if you are using Pythons. So we'll be focusing on vector operations. So vector operations basically is nothing like some kind of if you want to calculate the distance, calculate the area, or you want to perform attribute query, you want to perform special query. So, are you guys aware of some of the GIS terminologies, or do I need to explain those as well? For example, these attribute queries. Are you aware of these things?
Yes, ma'am.
Okay, okay, sure. So in yesterday's class, we covered some of the basic data types, variables, and what are the different environments that are present with Python, and few of the libraries like Panda and GeoPandas. Today we'll covering some different libraries as well. Okay. So in yesterday's session, what we did, we just uh, loaded a CSV file, inspected it, tried to know the column names, column information, and we also tried to get the information of that file that you are reading. And then after doing that, we also performed like how to know some kind of coordinate system information, all these things. So also, why coordinate system is important whenever you are working with the geospatial data? Can somebody tell me?
To visualize it in the proper place.
Yes, correct. So whenever you are starting or working with any kind of geospatial data or performing any activities, you really need to make sure that your data is in the correct coordinate system and projected. And if it is not in the correct coordinate system, you need to reproject it and make it into the suitable format and all those things. So,
Uh, Actually, I have a question from
okay,
yesterday's.
yeah.
Actually, you have told that we have to reproject it on projection system on 3857, I guess, and from
Okay.
the 4326 for the better visualization or the
Mhm.
better work performance. Why
Yes.
so?
So the reason was that is the UTM. UTM means universal. That is a universal coordinate system,
Yeah.
basically. So which is specifically for India. So as you are aware that that
Mm-hmm.
world is divided into different sections and different
Mm-hmm.
parts. So as our Earth is into a sphere format, not exactly sphere, but some kind of a irregular shape. So if you look into the Earth from a different angle or a different perspective, so if you just zoom out a little bit and if you try to do some kind of an calculation, those results will be wrong. Why it will be wrong? Because your calculation is always in the straight line, correct? But
Mm-hmm.
if you're calculating the straight line, if you're in a very zoomed out location, and if you try to calculate the area, it will always give you the wrong area. So if you want to calculate the correct area, you have to zoom in, and come at a position where you are actually getting a flat surface so that you will get the correct area calculation, distance calculation, all those things. So
Oh.
that's why when I said that you need to convert it into that
Mm-hmm.
format, UTM format from 4th year through 6th because it is the zoomed in coordinate system, projected coordinate system, which is specifically for India. And I am not saying that you should always prefer that only. Why? Because within India as well, we have different. India also lies in three zones, three or four zones. I'm really not sure, but I can check. India lies in 43 and 44, both the zones. So depending, because India is also a very big area in general. So within India as well, it will depend that are you working in Mumbai or are you working in Kolkata or are you working in Kerala? So depending on that, your projection system needs to be changed and adjusted accordingly. That is one
Okay.
thing. Yes, that
Okay,
is
thank you.
that is one thing that how you choose it. Another is you also need to know that what is the level of accuracy that you are expecting out of your work. That also depends on. If you really don't want too much of an accuracy, then it's fine. You can use any of the coordinate system. Okay. So mm, okay, so this I'm not doing the demo for the earlier to like the yesterday's session. I'll just go through once. So df dot head is basically if somebody wants to tell me why we use df dot head, like the variable name and then with the head function.
To visualize the data of first four results.
Yes, correct. And first five actually from zero to five.
Zero
So
two.
it will be
Yeah. Okay.
yes. And dot info basically gives you kind of a metadata kind of an information about your files, unlike that. And then next one is dot set CRS. CRS is basically it helps you to just if you want to just set the CRS of your layer. If there is, for example, you have uploaded a CSV and there is no coordinate system associated with your layer, how you will do it? This is for setting, for giving the CRS to your files. But if you want to change it or if you want to reproject it, for reprojection, the function will be to underscore CRS instead of set underscore CRS. So these are very small differences that you need to take care of. Then there is one new thing which is there, which is different from yesterday's session, is that what if you have derived some kind of an information and you want to create that and you got the output and you want to save that output into a file, then how do you do it? Saving that output into a file. So for saving it, you will just simply do out. The out is the variable name, means the layer or something where you have saved your information. Dot to file is the function name for saving it into a file. So yesterday, some of you were asking that earlier read.csv I used for loading the CSV files. So what are the other, how are we going to load other different formats? So for example, GPKG is one of the format like geo packages or SHP like shape files or GeoJSON like JSONs and all those kind of files. For those, we have read.file. Just one disclaimer, these functions will depend and change on what library you are using. For example, currently we are mostly working in the context of GeoPandas only. So these functions, for example, read underscore CSV, read underscore file, all these comes with GeoPandas. So if your library changes, for example, you are using Rasterio or you are using some different kind of geospatial libraries, for doing some kind of an operation. In those cases, for loading the file might change, these functions might change. So you need to take care of that. So yes, and then this out to file will be used. Then you will define the path here. After defining the path, you will give this driver. Driver is nothing, just the extension. For example, what type of file you want. So I wanted a GPKG file. So that's why I wrote here is equals to GPKG. And then always ensure that your coordinate systems are correct for all the operations that you are performing. So yesterday also we did some kind of vector operation. We worked with buffers, how to do the buffer, create the buffer and visualize it. And today we'll work with spatial joins, like we'll do the theory, like what are the spatial joins here? So some kind of spatial joins means if you want to do an attribute query, if or you want to do a spatial query. So the difference between the spatial query and the attribute query is basically that in spatial query, you give a geometry and you find out that one thing, a particular geometry is lying within the another geometry or not. Whereas within the attribute geometry is just defined by its name that from the column you fetch a value. Let's suppose you have data where you have 10 to 15 columns. In one of the columns you have city names and you want to filter something on the basis of the city name. So what you'll do that you'll fetch that column. Okay, fine. City is equals to Delhi. So is my uh, X feature lying within the city or not? These kind of operations basically we do with the attribute query operations just by the value within those cells. So also, yesterday I told you about there were three type of data: point, line, and polygon. There is one also multi-geometry. So polygon is a multi-geometry as well. So then for applying the operation, the basic operations are basically dissolve or overlay or measure the area or measure the length, like calculating the distance between one point to another point. So dissolve by itself, it defined that, for example, you have two polygons, and then if you just overlay one polygon over another polygon, and you want to make a single polygon out of that, then you will use the dissolve operation. Overlay, you just overlay on top of other. I'll show you the pictures so you'll get more clarity. Uh, just a minute. Yes. So here, if you see that if I wanted to just explain overlay, if you do overlay, within overlay as well, there are multiple operations. For example, do you want to clip it? For example, you want to clip A by B. So you just take out one polygon, another polygon, and you wanted to take out only the empty only the area which is lying between the both the polygons. So this will be the result because you want to clip A using the B. Then intersection. Intersection means keep only the overlapping part. Again here. So A intersection B. So it will give you the only the overlapping part between the two. Then next one is combine areas split by overlaps. Split by means A union B. So basically it will give you the overall area. And then keep parts of A, not B. So you only want some part of A and you want to remove the polygon area which is intersecting or which is lying within the part B polygon. So you will use the difference for that. And whenever you are performing any of these operations, again, I will mention that you need to make sure that the coordinate systems are in the same formats. It's in the also it should be in the measurable format. And one more thing, your CRS, the reason why we used the CRS that we were using yesterday is because that gives you the results in the correct readable, measurable format, like in the meters. So whenever you want to do any kind of calculations, you need to have that kind of an CRS, which helps you give the results in the measurable format. That's why we next is buffer. Buffer is nothing for creating a fixed distance buffer around those features. So, for example, if you have some point or polygonal line and you want to create some kind of an area around that, for that you will use buffer and all those things. Then special joins. In special join, there is a terminology called predicates we will use and the joint types. And there is a difference between all. So predicates are nothing. These are the functions. For example, you have two layers and you want to intersect between them. So if I'll ask you that what predicate will you use? So Can somebody give me one example? Otherwise, I'll give you for the intersect. If you have two layer, in what situation you will use the intersect special joins? What will be the problem statement for intersect? Okay, so let's suppose you have a boundary layer for the whole country, and then you have the road networks, and then somebody says that I want to know that which of the national highways are lying or crossing through which states, or yes, we'll take national highways from states only. So from which state, if you want to derive that information, so how will you do it? So then in that condition, you will use intersect, because you will take a layer of your road network and you will take a layer where you have the boundary layer. So you will do the intersect, that your road network is intersecting with which boundaries of your particular state. So that will give you that, okay, fine, these national highways are intersecting with these particular states, so these are lying or crossing through these states in those situations. Within maybe you can use for filtering out the POIs. For example, you are living in a certain area and you want to know that if you live in an X location, so from your X location, let's suppose you draw a buffer of 10 kilometer and you want to know that within this 10 kilometer, how many hospitals are lying or how many schools are lying. So in that case, you will use a within. So within will give you the result which are completely lying inside those bounding box or inside those geometry of a polygon. So it will give you within. So preferably, it's not like you cannot use within with a point or line, but it's always preferable that you use within with some kind of a geometry, which is a one geometry should be polygon between the two, where you are trying to do the spatial join kind of a operation. And then contains is similar like spatial join, but for example, if it touches with the boundary, then also it will give you in the result. Whereas in the within, if it touches with the boundary, it will not give you in the result. It should be lie completely within that polygon boundary, then only it will give you the result. Next is left, right, and inner. There is a difference between joint types, like how you want to join two layers. So, for example, you have two layer, and in both the layer, you are trying to do some kind of an intersect within or contain operation. So, if you will do the left, so left means that it will from first layer, it will bring all the features, values, irrespective if it matches or not. But from the second table, it will bring only the values which are matching. Rest all will be zero. Whereas in the right, same thing, just reverse it. That if you try to join it, then from the second table, it will bring everything, even if it matches or not. But from the first table, it will only bring the values which are matching with the second one. That's it. And in the inner, it should match all the values, only it will take out the values or the features where all the values are matching, and it will just remove or it will not bring out in the result of the values which are completely not matching. So yes, I'll now just stop, and if you have any questions, whatever I just told you, you can just first ask me, then I'll move ahead in this. Hello, anybody? Hello, are you there? You can just speak yes, no, maybe.
This one, no further questions.
Okay. Okay, then. So I guess these things are also clear. There is one thing which is missed about the multi-geometries that I forgot to cover. Basically, multi-geometry means multi-point, multi-line string, and multi-polygons. So means if you can have multiple point geometries as well, which may lie in different position, which may have different latitude and longitude. But if you are using that multi-geometry thing, in that case, those all points will be treated as one single point and one single line string. But those use cases are very different. Normally, in normal cases, we only have single point, single line, and single polygon. And within the polygon geometries is just that polygon geometries are formed as a ring feature. So we have ring created if we are creating a polygon. Uh, Now, there are some syntaxes for the joins and overlays that we just discussed. Syntaxes are basically GPD. GPD consider it as a normal, like a variable. Dot sjoin. If you want to do a special join, you will do sjoin. For example, if you want to do the nearest, then you will do a special join nearest. And then the predicates that I was discussing, you among all these three, you can use as per your choice. For overlays, the command will be the GPD, means the variable name or where you have loaded your file, your data, whatever, dot overlay. For intersection, union, difference, and symmetric difference, all these things will be used there. Then clip OI and erase area as common workflow. So this I was explaining in overlays here as well. So if you want to clip certain part, then which way you will use depending upon your use case. This will be cleared when we'll do the demo as well. So do the demo of clipping the AOI from one. We will have two layers and we'll try to discard some of the area and keep the rest of the area. Then you can also perform certain geometry operation like buffer, distance calculation, centroid calculation, area, length, and then you can also merge the two polygons with the help of attribute. For example, you have these two polygons, and let's suppose, even though the geometries are not touching each other, but let's suppose instead of these district and park or lake, they have a common attribute. For example, let's suppose that the renovation work of these park and this district is done, for example. So, and you want to make it a single polygon instead of two different polygon. In that case, you can perform this particular operation of dissolve. So you will dissolve or merge by attribute. So it will just take the outer geometries and it will try to join it all together and it will make it a single polygon instead of a double polygon. So that are the use cases of dissolve. Then aggregation. Aggregation is basically and mostly used for statistical studies, but in GIS also we have statistical information as well along with the map. So, for example, group by. So, if you want to group by some kind of a category, you have some kind of in data. Let's suppose you have lakhs of data where different features are there. For Delhi, you have 100 features, but you want to group by and count maybe for Delhi, how many hospitals are there? For Ahmedabad, how many hospitals are there? So in those cases, you will use this group by aggregation uh, method and get some kind of an inferences from this. Okay. Next is spatial index. So this spatial index is very important. Just like we give the indexing in our normal data set. So spatial indexing means we also give the indexing to each feature, each geometries, and all those things. So that it doesn't miss any of the line, for example, it's a polygon. So if it's a polygon, there are many geometries which combine and make a single polygon. So for that, special indexing is also very important. So for that, there is a library called Shapely, and which is a backend installed within. It comes within the GeoPandas. You don't need to separately install that Shapely. But it just telling you, if you are not using the GeoPandas or you are separately using, for example, Panda, in that case, if you want to do spatial indexing, you need to install this Shapely library for that case. Also, let's suppose you are creating the data, you are updating the geometries on the go while you are performing the operations. In that case, also, you will need the Shapely library. Okay. So now let's see more about this special join. So special join, intersect means any overlap or touch. If it's there, it's come in intersect. For within, you will use in the cases where A point will lie completely inside B point. Then in the case of contains, uh, B completely contains A. And then touches means boundaries sharing and no area overlap. And both the layers should have the same coordinate system. Then join means how means so left, as I told you earlier, also keep all from left. For example, parson add zone attribute only. Inner means keep only the matches, and right means keep all from the right attribute. Then data context here is nothing. Polygon with attribute, for example, partial ID and zones, polygon zoning class means for example, if you want to do a spatial join, you should have a common field between the two. Then only you will be able to perform the spatial join operation. So let's do this practical for now. Before this, there are few libraries also. I wanted to GeoPandas. I told you yesterday only that it helps you with geometries like point, polygon, reading it, and creating the. For example, you want to read the geospatial data set. You want to perform some kind of a basic operations for all those things. You don't need any extra libraries. GeoPanda will do all your work. Shapely is specifically for handling the geometries. If you want to extend, add, or update any point, geometry, polygon geometry, line, string, all those things. PyProject is basically helps you for coordinate reference system, transformation, updation, all those things. Fiona is also one of the library that helps you read and write GIS vector files. So as I was telling you that read underscore file can be used for reading shapefile, GeoJSON, and GPKG. So in case if you are not using GeoPandas, so in that case, Fiona can also be one of the libraries which can help you for reading those GIS vector files. Only the vector files, not the raster files. Okay. Artery is also one of the library which is uh, helps you with special indexing, like Shapely also helps you with special indexing, and it can help you with the special join and all those things. Whereas GeoPanda is a complete package. It gives you everything. Okay. So let's do this first demo for the Shapely before going to the special join. So, for example, you don't have data. You just wanted to create some kind of a data, then how do you do it? So, we have just imported GeoPanda library as GPD. Then after that, from Shapely.geometry, import polygon. Why we imported polygon? Because I wanted to create a layer with the polygon geometries. So that's why I have defined and imported polygon. I told you yesterday why we use import. Somebody tell me quickly. I want you to tell me, please. Why do I use for import here? What is the significance of import? Yes, correct. For using the library. Thank you, Kaushik. So if there is anything, if you have installed your library, but let's suppose you want to use it in your code, then in that case, there are, because within a single library, there are multiple modules. There are hundreds of modules. So how will you define, not in a single time, if you'll just keep on importing, it will just crash your CLI. So in that case, what you will do, you will just import whatever you want to, as per your use cases. So currently I needed to create a polygon layer out of this library. So that's why I only imported polygon. Then here I defined a variable zones, then GPT, because I have imported GeoPandas as GPT, the alias, geodata frame. Yesterday also we created a geodata frame. So in the similar way, we are creating a geodata frame. These are the column names. We have defined the column names. After defining the column names, now what we are doing, we are creating a list. We discussed about list also yesterday. So list is one of the data type where this is the way how you create it. You put the values inside the square brackets, just like this. Then zone name, this will also be a list. Just imagine it like a rows in the columns. So zone ID, zone name, and geometry are the column names, whereas these values are the rows values. Then in geometry, you can see that we have these polygons. We have just defined the polygon latitude and longitude. Just for the sample, we did it. Maybe it's wrong, but like just for the sample, I'm telling you, this is how you define the geometries. Along with that, then you'll close these curly braces, put a comma, and then we'll also define a coordinate system to our layer. Because if we don't define this coordinate system, it will not just be like a normal attribute information. It will not be called as a special data until unless we define a CRS. Then at last, what we did, I just wanted to save it into my drive. So I defined a path of my drive with the extension of the file type that I wanted. And then in the driver as well, I put the file type and then zones to file. And when I run this command, it just came into my directory, the path that I defined from here. Is there any questions to anybody in this? Okay. Then at the end from here, okay. So again, this is also the same thing that I wanted to create a parcel data. So I just created a parcel data from here. Now, how will I read it? From the GeoPanda, the function to read the file is read underscore file. So read underscore file. I stored the file path files into the parser and the zone. Now, I wanted to know what are the columns that are present in the parcel. So when I just did parcels.column, it gives me all the name of the column from the parcel. I wanted to know the zones column. So I did column. So it will give me the name of those here. Okay. So we just read the file, and now if we want to convert into the correct coordinate system. So how will you do it? So if you want to convert into the coordinate system, so you will just define it and convert it. Now I wanted to know the coordinate system, so I will do parcels dot ers. So now the CRS is this. It gives me this. After that, once it's converted into the desired, now we will do the spatial join. So first we will start with the left join. So simple, we used the name of the library, the alias that we have, gpd dot sjoin. Sorry, gpd dot sjoin. And then after that, we define the layer names, that within which layers we want to do the spatial join. So we wanted to do the spatial joins within parcels and zones. So first layer is parcel and second layer is zone. Now we'll define how. So how you want to do it? Do you want to do inner? Do you want to do left or right? So I want to keep all the parcel feature values, irrespective if it's matching with the zones or not. So we'll just keep all the parcels value. Whereas from the zone table, we'll only bring the values which are matching with the parcels. Otherwise, those values will be NA and those values will be empty. So before doing this, let's also do the head. So you can see these are the heads of my parcel. And if I want heads of the zones, so we have in zones, we have zone ID and zone names. So we want to join these zones with the parcel. So now we have what we have to do, that zones are the polygon geometry basically. Zones are the normal polygon geometry and the parcels are also the polygon geometry, and we are using the within. So what within will do? It should lie within that parcel. So we are doing that if the zones lies within that parcel, it should give the information. We'll just simply run it and then we'll try to print it. So now see what it just printed. So it earlier you can see that it printed NA in the values where there is no information of the zones, because we have only two entries for the zones and we have 1, 2, 3, 4 entries for the parcels. Now we have 4 entries for the parcels because I did left join. So I bought all the attributes from the parcel layer, whereas from the zones, I said that whatever value is there, just keep it. And if it's not matching, just put it 0. So that's why it's there. It's coming here. And the last one, it was NaN. Whereas it matches, so it gave me. So this is how we do the spatial join. So do you have any questions in spatial join? Using the within. Then I'll move to the inner one also. This is clear? Okay. So now let's do the inner join. So no difference. The only difference is gpd dot sjoin, both the layer name, how will be inner, predicate will be intersect. So you tell me, now I want you to speak. Somebody should speak that what this gave me. What do you interpret from this? Because I'll just keep on speaking, and if you don't understand, there is no point of this.
Ma'am, it will give the first five rows.
No, the head will give you the first 5 rows. I'm asking about this operation that I perform now, the inner and the intersect. What this special join will give you if you'll use how as inner and predicate as intersects.
So it will give, it will intersect in two layers, and whatever the common columns are there, they will getting reflect.
So basically, inner means inner. If we use inner and intersect, I told you here also. So intersect means any overlap or touch. So if between the two geometries, because both were polygons, the parcels were also polygon and the zones were also polygons. So even if they overlap, they will give it. But we use the inner one, keep only matches, intersection of both. So right now, what we did, it should overlap or touch anything that we'll keep, but it should intersect with both the polygons. So that's why we only got three entries, because these were the only three entries that were intersecting and overlapping with with both the polygons. That's why we got only three entries. Whereas here, when we did the within and left, then we got all four entries. Why? Because in left, it doesn't exclude anything. It keep all the attributes from the first and it just joins from the second. That's why we got four entries. Whereas in inner and intersect, we got only three entries because it takes only the overlapping ones. Then the last one is, let's do unmatched. Let's see which is the one which is not matching with any of the polygons. So for that unmatched, what I did is, let's try to break this statement. Okay, so J within is my variable name, or you can say the layer, consider it as a layer. Then within that, I took out a column name. So within within, you can see that we have parcel ID, owner, geometry, index zone. So I wanted within J within the fetch the column name index underscore zone is NA, that check if it's null or not. If it's null, then it should give you then and dot sum. Basically, it gives you, it's just checking that if there are, let's suppose, 0, 1, 2, or anything, is just check from here and then just run it. It gives you that which parcels are without any zone. So it gives you that only one parcel is without any zone. Why? Because only one entry is there where index underscore zone value is NA. Why specifically I checked this particular column, not parcel ID or anything else? Why? Because I performed a left operation with within. So this was the first column of my second layer. So I have to check from my second layer columns only that which is the unmatched column, or uh, which doesn't lie within the spatial join. So because only the feature have NaN value in the case when it doesn't match with any of the features from the first layer. In that case, only it will have null values. So that's why I checked it and printed. So you got the information that there is one parcel which is without the zone. Okay. So we also understood this overlays as well, but we'll just keep it till here only for today's class. So I want you to read more about these special joins and overlays and all these things. That theoretical part I have covered. Only thing is left now is the practical part. So in Monday's class, we'll cover all these practical classes. We'll just start with the demo, that how to do the attribute filters, how to do the special query. Basically, we'll move into the query part that I told you yesterday. I have included. We'll also perform nearest neighbor joins, and I'll explain you more about nearest neighbor. Nearest neighbor is nothing basically that if you want to do those kind of operation that within 5 kilometer, how many POIs are lying. For example, your home is at X location and just you want to know that within 5 kilometer, uh, how many walkable hospitals, how many walkable schools or rest stops are there. For all those kind of applications, we use nearest neighbor. So we'll just directly do the demo for nearest neighbor, and then overlays. Also, I'll cover the clipping part, and then the theory is covered for attribute filter and special query. Only the demo is left for this, that with the help of layers, how do you do the attribute query actually? Joining is done. Buffer we already covered yesterday. That's why I'm not covering it today within the vector operation. Then this is also, I covered yesterday, the basics of coordinate system, geographic versus projected. So basically, geographic coordinate system are those which are not very friendly for calculation and all those things. And for any kind of calculation, if you want to do, you need to use those projected coordinate system. So just study all these things as well from this PDF. And if you have any questions, you can just bring it on the next class, and then we'll directly do the hands-on session on the next session. Okay. If you have any question till now, whatever I explained about the spatial join and all those things, you can let me know. There is one more thing. For today's session, I covered spatial join, so you can just perform this hands-on exercise for spatial join. The plotting also I covered yesterday, how to do the plots in the map and all those things. So you can just combine yesterday's session and today's session and do a hands-on activity. And it's a 2-day time for you guys. So on Monday, first we'll see what all you have done, and then I will start with the demo for the special queries, basically. Okay. Any questions now?
Ma'am, please share today's and yesterday's.
PPTs? Okay.
Yeah,
Okay. I will share both the PPTs.
sure. Thank you.
Thank you. I really want you guys to come with questions on Monday, because it will help me also to understand that what I need to focus more. Okay.
Okay.
One request, ma'am.
Share.
Please, can you, in Monday's session, can you please explain about joins like inner join and outer join?
Okay. Yes, I'll cover that. Special join I already covered, but
No,
inner join and outer join I will cover.
yeah,
Then.
that's all right.
Okay. If also one more thing, you have the group. So if there is any topic or anything you feel that this is because you have the curriculum PDF, I guess. So I'll be going through with that curriculum PDF only. But if you feel that within those topics itself, I might have covered only few things and you need a little bit more stress on some other libraries specifically, then you can ask me, then I can just make or create something for you guys in the demo and then bring up in the next sessions. Or in the chat, you can just post it so that I can cover that also.
Ma'am, can you share the questions so that we can do?
The questions, in this PDF only, no, you can see that. Just a minute. Yes.
And ma'am, one more thing is there, like if possible, like
Mhm.
before start the class, if we are getting the shape file, whatever you are using in the notebook, so we can also do at that time. So that will be very easy for us to do.
Yes. Okay, fine. So I'll incorporate. So basically what we can do now is we'll do this demonstration together. Maybe we can do that. So I'll just keep on, instead of just telling you one by one, I'll just keep on doing one thing, and you can also simultaneously do one thing. I'll just share the data also.
Yeah, that will be better, ma'am.
Sure. Okay, done. So data is one thing, and then inner join and outer join, and anything else also, if you want, you can just give me that one day before the class, and then I will incorporate that in the next class. Okay.
Okay, ma'am, thank you.
Okay. Thank you, everyone.
Thank you.
Thank you. Bye-bye. Good night.